Today we'll be looking at how to calculate the percentage purity. This is a table showing us what really happen in a chemical reaction, in a titration reaction. In this titration reaction, what we have here is that A contains 14 grams of impure sodium hydrogen tetrasulfate 6 per dm cube, and B contains 4 grams of pure sodium hydroxide in 1 dm cube of the solution. Now, at the end of the iteration, we're able to have this result. This is our result, and from this result we're expected to calculate the amount of sodium hydroxide in 1 dm cube of B and concentration of sodium hydrogen tetrasulfate 6 in mole per dm cube of A. The next question there is mass of sodium tetrasulfate, sodium hydrogen tetrasulfate 6 in 14 grams of the sample. And the final question is percentage of sodium hydrogen tetrasulfate 6 in the sample. Now we have the relative atomic masses of the compound elements involved, and then this is the balanced chemical equation of the reaction. From what we have as our result, what the first thing we do here is to take the average, to calculate the average of the AUs. To do this average of AUs, what the most important thing you should note here is that you should check the ones that are close to each other in volume. In the volumes, if you look at this volume, it's important that you don't use any of the any of the values that has a ratio, a difference of more than plus or minus 0.2 cm3. Anything that's more than this should not be used, but anything that's less than this can be used. So from what we have so far, you'll be able to find out that relatively all of them tends to have a difference of not more than 0. Plus or minus 0.2 cm3. So what we're going to do here is that since they have that they fall within this range, what we're going to do is to use all the values, all the volumes that we have here, and take the average in order to calculate the average volume of AUs. The average volume. The average volume will then be the average of A will then be 23.4 plus 23.3 plus 23.2 all over 3, because they are 3. We know we are looking for the average. So if we sum up the whole of these things, what we have will be 69.9 all over 3. That will give us 23.3 cm cube of the A that we use. So with this information that we have here, the next thing we are going to be doing is to calculate what we are given, so that we calculate the amount of sodium hydroxide in 1 dm cube of B. Now, looking at that, you find out that the sodium hydroxide we have here is 4 grams. That means 4 grams per dm cube. Then to get the amount, what we are going to do now is, remember, we have the mole is equal to mass over molar mass, and we have the mass in 1 dm cube of the solution of B. We have it to be what? 4 grams per dm cube. That is what we have. In 1 dm cube, it contains 4 grams. So in the molar mass of B, will then be, remember, since it's sodium hydroxide, sodium is always 23 from what we have there, and then hydrogen is always 1 plus oxygen, which is 16. So when you add up everything we have, it will give us 40. So then we have 40. Since we have 40, what do we have now? Remember, we're going to be using this. Since we are going to be using this, what we have will be 4 over 40. That will give us 0.1 mole, 0.1 mole per dm cube. 0.1 mole per dm cube. So since we have 0.1 mole, that is the concentration of or more amount of sodium hydroxide in 1 dm cube. That is 0.1 mole per dm cube. That is what we have. So the next thing, the question said we should calculate the concentration of sodium hydrogen tetrasulfate 6. So to calculate that, we are going to be using our, I think I should keep these things here so that we will not miss it out. Okay, we'll have everything we need. The average volume of A is what? 23.3 cm cube. Now we are looking for the concentration, which is unknown. We have it as unknown. The volume of B is 25. That's what we use in the titration. And then the concentration of B is what? 0.1 mole per dm cube. Remember, 0.1 mole per dm cube. Now, having this information, the next thing we're going to do, you look at the ratio, the mole ratio here, because there is no numbers here. That means the coefficient of them is what? 1. And in that case, we normally consider it as mole ratio. So with the information we have already, the next thing we are going to do is to get the mole ratio. The mole ratio of this reaction, because we have sodium, we don't have any number here. So the mole ratio of sodium hydrogen tetrasulfate 6, that is the A, is what? Is 1 mole. 1. That's the mole ratio. Let me just put it this way. Mole ratio of what? A is what? 1. And the mole ratio mole ratio of B is equal to 1 2. So now we can now use our formula, which is CA and BA. This one is now CB over BB equal to A over B. That's for the mole ratios that we have. So the next thing we are going to do is to substitute this. This is what we have here. Substitute the numbers that we have. So in that case, let's go up a bit. Let's go up a bit. So A is for what? The unknown, which is C times volume of A, which is 23.3, all over volume of concentration of the B, which is 0.1, times volume of B, which is 25, and the mole ratio is 1:1. So the next thing we are going to be doing here, then we'll cross multiply. If we cross multiply, that means 1 will multiply what we have up, all the numbers we have here, and this one also will multiply what we have down. So if we do that, what we have is 23 CA equal to 0.1 times 25 times 1 times 1, 2. So everything will give us, okay, I've already done that. That means CA will be equal to 0.1 times 25 over 23.3. So the next thing is we'll have 2.5 over 23.3. We divide this it will give us, let's see what we have. We have 0.107 mole per gm cube. Per gm cube. Now, we have the concentration of A in mole per gm cube. So the next question there says that we should calculate the mass of A, that is sodium hydrogen tetrasulfate 6 in what? 14 grams of the sample. Note, this sample tends to be impure. It's impure sample. So we are going to find out what's the exact mass of sodium hydrogen tetrasulfate 6 that is there. Now, remember, impurities in this calculation now, impurity did not involve in the reaction because we're looking at what happened between the pure sample of sodium hydrogen tetrasulfate 6 and sodium hydroxide. So this is what happened. The reaction between them, they reacted in a mole ratio of this 0.107 mole per gm cube. That's for the sodium hydrogen tetrasulfate 6. Now we are looking for the mass. You know that, remember from the previous formula we use, we know that mass is over what? Mole is your mass over what? Molar mass. Molar mass. Since it's molar mass, we don't know the mass this time, but we know the mole. The mole of A with 0.107 mole per gm cube, and the molar mass is equal to 120 gram per mole. Now if you don't really know how to do this, to get this molar mass, what you just add up is the relative atomic mass of this, relative molecular mass of that. When you add it up, multiply 16 by 14 plus it to 32, all the rest of them. Before by the time you finish up the addition, what you get is 120. So then, if you cross multiply this equation, we have mass equal to mole times molar mass. And molar mass, we have it to be 0.107 times 120. That will give us, what we have here will be, let's see what we get, multiplied by 120. It will give us approximately 12.84 grams. That's gram per gm cube. That's 12.84 gram per gm cube. That's what we have from our calculation. So the next question there said that since we have the mass of this, calculate the percentage of sodium hydrogen tetrasulfate 6 in the sample. So to get this one done, what we are going to do again, remember we have the mass of the pure sodium hydrogen tetrasulfate 6. To be what? 12.84 grams, and the mass of the sample, mass of the impure sample as given, sample is what? 14 grams. So the percentage mass of that will then be 12.84 over 14 times 100 over 1. So going by that, what we have will be 19.7%. That's the final answer. All right, thank you so much for being part of this class. If you are joining us for the first time, we encourage you to subscribe. And then if you have any question, you can leave it as a comment. And then make sure you share. And then remember to watch some of the videos that are coming after this. Thank you so much.